Okay, and welcome to the tutorial on the second half of parabolas. Today we're going to be looking at one objective, and we're going to be able to write the equation of our parabolas in standard form. So just to review, there are two standard forms for our parabolas. The first one is for a vertical parabola, and that would be x minus h quantity squared is equal to 4 times a times the quantity y minus k. There's also a horizontal standard form, and that is y minus k quantity squared is equal to 4 times a times x minus h quantity. So if you're looking at both of these standard forms, we're going to be writing them into this. Really, the only things we need two pieces of information, similar to the circles. We needed a center and a radius. For parabolas, we will need the vertex, because that will give us the h and the k values, and we'll be able to plug them in to our standard form where they need to go. We will also need the value of a. And a can be given in numerous ways. I could just flat out give you a, and if you know what a is, then you can just multiply by 4 and put it into your standard form. I could give you a focus and a vertex, and you need to know the relationship between those two. I could give you 2 points of symmetry, and you could figure out what a is. I could give you the vertex and the directrix, and you could figure out what a is. There's a bunch of different ways I could give you enough information for you to find what a is. So once you find h and k from the vertex and the value of a, you can write your standard form if it's a vertical or if it's a horizontal. So this is the information that we're going to need today, the vertex and a. This first problem is asking us to write the equation of the parabola that has the vertex at the origin. Its axis of symmetry is the x-axis, and it contains the point -1/2, comma 2. So this is actually a point on our parabola. So we want to write the equation, and then once we have that, I'd like to state the focus and the directrix. Let's first talk about some of the pieces in our problem. We're given the vertex is the origin, so we know that 0, 0 is our vertex, so there's our h and there's our k. That's nice. We also know that the axis of symmetry is the x-axis. So I always have a little piece of graph paper here, or a little graph. I think a visual is helpful, at least for me. So I'm going to go ahead and put my vertex right here on my graph paper, and I'm actually going to label it with a V. Because if I'm going to be putting a bunch of dots, I need to know which one's the vertex, which one's the point of symmetry, which one's the focus. So there's my V. I also know that my axis of symmetry is the x-axis. If I dot that in, my axis of symmetry here, that gives me what this parabola is going to be. You should now know that your parabola is going to be a horizontal parabola. Our parabola could be going this way, or it could be going this way. But the axis of symmetry does cut it exactly in half, so I now know that I am dealing with a horizontal parabola. And since I'm dealing with a horizontal parabola, I know that I'm talking about this standard form. Y minus k quantity squared is equal to 4 times a times the quantity x minus h. I know that this is ultimately what I want to plug into. There is one more piece of information, and that is that the point -1/2, comma 2 is on our parabola. If I graph that, -1/2, 2, that is a point that's on my parabola. That now tells us that we must be opening to the left, and that therefore a must be a negative. But we'll figure that out. You might say, well, if -1/2, 2 is on our parabola, wouldn't -1/2, -2 also have to be on our parabola? And yes, that's true. So we can plot that in. Maybe that's helpful. Now, what I don't want you to assume is that just because these are 2 points that are on our parabola, I do not want you to assume that these are the points of symmetry. Indeed, there are infinite pairs of points that would be symmetrical, but there's only 2 points that actually have the vocabulary word of points of symmetry, and these actually are not those points. We'll talk about why in a minute. Okay, so we do know that our parabola is going this way. And I do know that my h and k are both 0, so I can just plug those in to my standard form right now. So I'm going to get y minus 0 squared. Well, y minus 0 is just y, so that just becomes y squared. I don't know what a is yet. And x minus 0, well, that's just x. So my equation has become a little bit simpler. Really, I'm just looking for this value of a. I know that it's negative, and I know that because my parabola is opening sideways, but I do need to find the actual number. Well, that's where this other point is going to come in handy. This is a point that's on our parabola, which means that when we plug this point, this x value and this y value into our equation, we will have truth. So I can use this negative 1/2 as my x value, and I can use this 2 as my y value. I'm just plugging in this ordered pair. I could easily have plugged in this other one that we had, negative 1/2, negative 2. I could have done that as well. And now you can see that everything's just a number except for a, so we should be able to solve for a. This becomes 4. This is 4 times a. Well, we can do that math. 4 times negative 1/2 is negative 2, so negative 2 times a. And we're almost there. Let's divide by negative 2. It looks like a is going to be negative 2. Since we now know what a is, I can plug that in right here, and I have my answer. Y squared is equal to negative 2 times 4 is negative 8x. This is the standard form that would have the vertex at 0, 0, the axis of symmetry, the x-axis, and negative 1/2, 2 being one of the points on our parabola. We're not finished because we still wanted to know what's the focus and what's the directrix. Well, now that is pretty simple to find because once we know that a is negative 2, we know that the distance from the vertex to the focus is exactly a units, and since it's negative, we're going this way. So our focus is right here. I'm going to label that with an F, which is the point negative 2, 0. So there's our focus. And our directrix must be 2 units on the opposite side of the vertex. So here's 2 units to the opposite side. That's a point that's right on our directrix. I'll dot in our directrix. The directrix is a vertical line. In this case, it is the equation x equals 2. So we got our standard form, and we found our focus and our directrix. These are not the 2 points of symmetry, and we know that clearly now because since the focus is over here, the points of symmetry are going to be somewhere on this line. In fact, they're going to be 4 units above, 1, 2, 3, 4, and 4 units below, 1, 2, 3, 4, because they are exactly 2a units. And now we have a nice picture of our parabola if we wanted to graph it. The directions did not say that we needed to graph it, but that's a nice picture of it. Okay, let's move on to the next example. Let's read this. It says, write the equation of the parabola that has its focus at 0, 4, and its directrix is the line y equals negative 4. Okay, so we're given 2 pieces of information. I'd like to plot those pieces. This is 0, 4, 1, 2, 3, 4, and I'm going to put a little F for focus. And the line y equals negative 4, that's a horizontal line, 1, 2, 3, negative 4 units down here. So it's right here. That's the only information that's given. This should be enough information for you to figure out what type of parabola we have. Since the focus is up here, we know that the parabola is like a Pac-Man eating that focal point, and so the parabola must be a vertical parabola. And since we're talking about a vertical parabola, we know that its x minus h quantity squared is equal to 4 times a times y minus k. So now we need the the vertex, we need h and k, and we also need the value of a. Well, we do know the relationship between the focus and the directrix is that the vertex is exactly halfway between these two. And since we went 4 up and 4 down, we can all see that the vertex is right there at the origin. So the vertex is the origin, So h and k again are 0 and 0. So that is in our standard form, x minus 0 is just x, so this becomes x squared. And 4 times a times y minus 0 is just a y. So again, we're trying to find a. On our previous problem, we were given a point that's on our parabola to plug in for our x and our y, but we don't have that luxury this time. But we don't need it because it's a whole lot easier. We know what a is already. A is always the distance from the focus to the vertex. And since we're going upward to get to the focus, we got a is positive 4. If a is 4, we can just plug that right into our equation here, and we've got our answer, x squared equals 16y. Seems like a pretty simple problem there. A was easier to find in this problem than on the previous problem. Okay, moving on to our next one. Very similar. Write the equation of the parabola. This time I'm going to give you the vertex is negative 2, 3, and the focus is 0, 3. So since I have that information, might as well go ahead and graph that. We've got the vertex is negative 2, 3, so I'll go negative 2 and then up 1, 2, 3. I'm going to label that as a V. And I'm going to come over here and say the focus is 0, 3. So that's 0 and then 1, 2, 3. I'm also going to label that with an F because, of course, I wouldn't want you to lose your focus. Okay, I guess that wasn't really that funny. Yeah. Okay. Yeah. Okay. Sure. Okay, not many laughs out of that one. Okay, but that's fine. Okay. Sorry, guys. I'm just having fun with some of these sounds. And there we go. Let's get back to the math. So if we've got the vertex and the focus, this should be enough information for you to see that we absolutely are opening this way. And therefore, this is a horizontal parabola. I'm going to go ahead and mark that down. It's horizontal. Since it's horizontal, I know that it's the y minus k quantity squared is equal to 4 times a times x minus h. Easy. Now you do need to know the difference between those two standard forms. So we already have the vertex. In fact, we have that with h and k. If h is negative 2, then right here we're going to have the x plus 2. And if k is 3, then over here we're going to have y minus 3, quantity squared. Now we just need to figure out what 4 times a is. Well, a is basically given as well, because a, again, is the distance between the vertex and the focus. You do need to know if it's a positive or if it's a negative, and since we're opening to the right, that's the positive direction, a must be a positive 2. Since a is 2, we can plug that right into our equation here. 4 times a is 8, and we are finished. So some of these problems are pretty fast. Let's look at our final one. It is a word problem. Let's go ahead and go through this and see if we can solve it. We've got a satellite dish. It is shaped like a paraboloid of revolution. That basically means that it's 3 dimensions, but basically it's a parabola in a cross-section would be a parabola. It says that the signals that emanate from a satellite strike the surface of this dish and are reflected to a single point where the receiver is located. If the dish is 8 feet across at its opening and 3 feet deep at its center, at what position should the receiver be placed? Okay, so we do have a piece of graph paper here, and we don't have much information as to where this satellite dish is, but that doesn't really matter. We can put the satellite dish in any location that we want. We're given 2 pieces of information, that the satellite dish at its opening is 8 feet across, and at the center it's 3 feet deep. So I don't know about you, but since I get to pick any point in our Cartesian plane to put the vertex of this parabola, I think that it makes the most sense to put that vertex right here at the center, because 0, 0 is pretty easy to deal with. Okay, so we have a satellite dish, and you could be opening it this way or upside down. That doesn't make much sense. I'm going to open mine up this way. Now, I know that this is, the center ultimately of the satellite dish. We call that point the vertex. So it's 3 feet deep at its center. So I know that the satellite dish's opening is somewhere right around in here. And I also know that at its at the center, or at the opening, that it's exactly 8 feet wide. It says 8 feet across. So that must mean that 4 of the feet are this way, 1, 2, 3, 4, and that 4 of the feet must be this way, because it is going to be a symmetric paraboloid, 1, 2, 3, 4. So ultimately, this is a picture of our satellite dish. And again, we just chose to put it right there. Okay. Now, again, I don't want you to assume that these are the points of symmetry. These are just two symmetric points. They might not necessarily be the points of symmetry. In fact, I know that they're not, because if these were the points of symmetry, then this would be the focus. But since the focus is 3 units above, if this were the focus, if this were 3 units above the vertex, the points of symmetry would have to be 6 units away. So the math just does not make sense. The focus is going to be somewhere in here. In fact, that's what we're looking for. Where the receiver is going to be located is where the focus would be for this paraboloid, or this parabola in 2 dimensions. So I need to figure out, ultimately I need to figure out what A is. Okay, so we forced our vertex to be 0, 0. We drew a vertical parabola, so I know that it's vertical, and therefore I know the standard form that I'm using is x minus h quantity squared is equal to 4 times a times y minus k. I also, again, we were smart that the vertex is 0, 0, so these quantities basically become just x squared and y right here. So now it's really just about finding A. This is a very similar problem to the first example we looked at in this tutorial, where we had an ordered pair that was on the parabola. Right now we actually have 2 ordered pairs. The name of this ordered pair that I'm circling right now is 4 units over, 3 units up. So 4, 3. Where we placed our paraboloid, 4, 3 would be on the graph. So therefore, I can use that x and that y in this equation to go and solve for a. Since x is 4, I can say that 4 squared is equal to 4 times a times 3, since the y was a 3. Doing this math, I've got 16 equals 12a, and when I divide both sides by 12, I get A is 16/12, which would reduce to 4/3. We knew that A had to be positive since it's going up, and that looks like 1 1/3. So if I go up 1 1/3, this is approximately where our receiver will be. Word problems, of course, are answered in words, so I will say that the receiver is placed 1 1/3. We are talking about feet. Yes, yes, feet from the vertex. Yeah, from the vertex. Word problems are answered in words, and there we go. So 1 1/3, you could say 1.3 repeating. You could just say the 4/3 feet away from the vertex. That's where the receiver is. So as a pictorial, a picture here. These beams of the satellite, the signals coming from the satellite dish or from the satellite, excuse me, are coming into the satellite dish, and then they bounce off that right to the receiver. Every part of the dish reflects the signal into the receiver so that the receiver can, so that it can receive the signals. So that's a cool problem. Very similar to the first example. You can go back and look at that one. There are 2 final problems that I'd like for you to try. They're try 1 and try 2. If you would please push the pause button at this point and try your hand at each of these and then unpause so you can check your answers. Please hit the pause button now. Okay, thank you for trying each of these. I used the graph patches as a nice little visual for me. I plotted the vertex, I plotted the focus. I saw that it's going to be a horizontal parabola in this first one, and it is going in the negative direction, so that's why A is -10. when I put the vertex numbers into our standard form, and then I put a as -10 in there as well, this is my final answer. Try 2, I plotted this. I put the focus where it's supposed to be. The directrix was a little bit off the graph patch, but that's not a problem. I dotted that in. I counted the distance between the two, which happened to be an odd number, but that's okay. We can take half of 9 just like we can take half of any number. Half of 9 is 4.5. So that's where the vertex is, 4.5 units away from the focus, 4.5 units away from the directrix. If you count out that ordered pair, it's 1, 2, 3, and then up 1, 2, 3, 4, 5.5. So that's where I got my vertex was 3, 5.5, and I plugged those numbers into my standard form. Oh, I also knew that this was a vertical parabola because, well, that's just because what it has to be. So I knew that this was vertical, and I was using the vertical standard form. I also now need to figure out what A is, and like I said, A was 4.5 units away, so 4.5 units, but I also need to know that A is a negative because it is opening downward. So that's why A was negative, and that's why 4 times the negative becomes -18. Thank you very much for watching this tutorial, and I will see you in class so we can practice this some more. Bye-bye.